Good morning, everyone. I am Suchit Sharma and I welcome you to the GSG group study group. Uh, this is the revision video for D.B.M.S week 2. I would like to just check my stream that is it working properly or not. Is the my voice clear? Is the screen visible properly or not? Okay, so just give me a minute. Let's see. The name of the channel is Suchit Sharma itself. It may change in the coming future. Okay, we are live. We are live. Is the screen visible properly or not? So just give me a minute. So okay, so we are live and the stream is working fabulously. One more thing to check is the quality of the video. Okay, so you can take the video up to 720p is okay. 720p is pretty good resolution, I guess. Even if you don't, I don't think that would make any difference. Let's start with the session and go to week 2. You know how we do it. We go through the PPT provided right here in the supplementary content. We open lecture slides in PPT. Give it a while. Give it a second. Okay. We go to week 2. That's what we are covering. How many? We've got 5 PPTs. We've got 5 presentations. And as I just said that we have completed the session once before. We have, not recorded the session. So let me just remove each and every one of the answers. I promise you that this won't happen in the coming videos. I guess from week 5 there won't be such issues. So let's start. Let's just put it to the first one. Okay, it's first removing each and every one of them. Or what can I do here? Okay, right. Let's reload this page and let's go here. This week mostly focuses on relational algebra plus introduction to SQL. SQL, we know what SQL is. We covered it in the last week. Now let me tell you what SQL is pretty quickly. Let whatever you don't know, this is a really good method to understand and learn from for this degree. I know what SQL is. Still, let me just tell you how I learn it. What is SQL? What is SQL? Structured query languages. A computer line interact with relational database. SQL is a tool for organizing, managing, and retrieving data from computer. The original name was given by IBM, Structured English Query Language, abbreviated by the acronym SQL. Okay, so people do call it SQL, people call it SQL, I call it SQL, call it whatever you like. Even sir call it SQL, but let's see.
Sequel.
See, even the computer is calling it SQL. So let me just tell you that I will be calling SQL, and as I am, I learned the whole PPT with the term SQL. Okay, so what are the module objectives? To understand attributes and their type, to understand mathematical structure of relational model, to familiarize with the different type of relational query languages. Okay, so in this particular module we would be covering attribute type, relational schema, instance keys, relational queries. Okay, PDF 2.1, let's start. Okay, example of relation. This is an example of relation. Okay, let me just tell you what a relation is. So prerequisite for this DBMS course is you should know and you should understand set and set. set algebra. You should know union, you should know intersection, you should know uh, let's say relation. So what a relation basically is, it is a Cartesian product between two different tables. That's what it is. It's just a Cartesian product between two different tables. This is a relation. This table is called a relation. Let's move forward. What are attributes? Attribute. The set of allowed values for each attribute is called. Okay. So this is a domain. The set of allowed values for each attribute is called domain of the attribute. Okay. So let's say this is an attribute. ID is an attribute. Name is an attribute. Department name is an attribute. Salary is an attribute. But the type of data, the metadata, domain is basically the metadata, data about data. So it is numeric for ID. It is variable character. Usually char also works, but it's better to use varchar. Varchar, varchar for department name, and again numeric. Sorry, that I don't think it was numeric. Let's check what it was. Maybe I'm getting this one thing wrong. Or let's wait. It would be covered later on. Numeric is also a type, but this is not the example for the given table. Okay, it would be provided here, I guess. Mm-hmm. Number. Okay, so number is the domain here for Aadhaar card. Uh, Attribute values are normally required to be atomic. That is indivisible. Let's elaborate this line. This line is pretty important, uh, so as to make you understand the conceptual base for this whole building. An attribute that cannot be divided further into meaningful subcomponents is called atomic values. Atomic means indivisible. Atomic data is most detailed information. Okay, the value is atomic for purpose of normal form if and only if let's see, is there somewhere what is let's find what are atomic values in SQL. Okay, so I am also starting to call it SQL. SQL and SQL would be used simultaneously. Okay, atomic in code original atomic meant not relation valued, not table valued. Okay, so far we have discussed examples. Let's see what is atomicity. Atomicity in database, atomicity is one of the asset. Okay, atomic consistency, durability, transaction. An atomic transaction is indivisible, irreducible series, such as either all occurs or none occurs. Okay, so this is the practical line. Either all of it occurs or either none of it occurs. Okay, so let's say you are transferring 10,000 rupees from bank A to bank B. Either the transaction should succeed or it should not happen at all. It should not be like you're transferred to you were transferring 10,000 and now only 2,500 of the initial amount is transferred and the rest is stored in bank A. That would be not an ideal situation for our given condition. A specific value null, a specific value null is a member of every domain. So let me tell you, let's say you have id for let's say you have id for each and every name, each and every id. You have department name, but you are not provided with the salary of Mozart, that is 15151, who teaches music. So what will you do then? You could not put it zero because zero itself is a number and signifies that Mozart is working for free. You should have a specific type of data to denote that there is no data available. So null. Null data denotes that the data is not available for a given cell, a given a given tuple attribute, a given instance. Instance would be the right word. The null value may cause complications in definitions of many operations. Yes, that is true. See, as I just said, that the value is unknown indicates that the value is unknown. Let's see attribute types. Okay, alphanumeric string, alpha string, date, string, alpha string. Let's skip this. This is not important. Schema and instances. Okay, let's. This is where the important stuff starts. Let me check if I have an Excel for this. hmm I think I do have. I guess it was it this data set or which one? I manipulated the data for one of this. Just give me 1 second. I have to check which one is it. The file that we used last time. Okay, so I guess it was in downloads. So Chama downloads. Mm-hmm. Dataset 3. Let's go with dataset 3. Okay, so I guess you are pretty familiar with this table. Okay, we used it in the last video, and I will be using it again in this video. Let me do this one thing first. Let's color it this, and I am reversing the colors because someone told me to. I have no issue in coloring in vice versa, but someone told me this is good, so this would look good and you would understand it better. So this is a table which we would be using again, because this is data. This is data. Although opened in an Excel sheet, but this is data. In SQL, you would be using data tables in SQL, in the application of SQL. Here I am using Excel sheet to make you understand the concept better. Okay, let's say A1, A2 until AN are attributes. So let's call this states A1, this A2, this A3, D1, A4, even A5 till, let's say, it goes here till AQQ, but let's say it goes out for infinity, right? And we call it AN. We call it AN. These are just notations so that you understand. A relation is A1, A2, A3 in a relational schema. Okay. So when I define a relation, I say, okay, give me this attribute. Give me attribute A. Give me attribute B. Give me attribute C. Give me attribute D. Along with attribute of which one is better? Okay, so let me choose the state of the attribute A. State, I need attribute B, whether he lives in urban or rural. Attribute along with attribute this income. Okay, I just need these three attributes and nothing else. What will I do? I don't know how to change this, but let's say what the table would show me is something like this. Let's say I defined a relation where I needed just these three attributes. So the table would show me just this much and nothing else. The output of the table or output of the query that I put in would be this. This is a relation. I chose a specific attribute. You can choose the attributes as you like. Let's say I need one attribute. Let's say I need two. Who can tell how many attributes you would need? Let's say I need attribute A, attribute C, attribute E, and then attribute H, and nothing else. So what this would do is this would make all of them and this would take all of them and compile it into a singular table. and will not show anything else, just as I showed you. Okay. These are called relation schemas. These are called relation schemas. Formally, a given set D1, D2, Dn is a relation, is a subset of this. Okay, the same thing that I just told you. The current value is relation instance of a relation is specified by a table. The element are represented by a role. Okay, done. This is pretty much it. Relations are unordered with unique tuples. Okay, so now as let me go back again to this. Mhm. Okay. Relations are unordered with unique table. So while entering data, while the table is shown as an output, it is unordered. As you can see, let me show you just this one. Okay, let's focus on this income group one. It is unordered. I have 2.5 lakhs here, and then just below it, it is 3 lakhs. Then again 2.5 lakhs. How is it ordered? It is not ordered. So let me try to just order it once. Let's order it. I guess I have something, a way to order it, or mhm. Is there some way I can order it? Sort A to Z, custom sort. Okay, yes, I have custom sort. So let me sort by income group. Let me sort by income group. Okay. See, now it is ordered, but I have to, I had to do some functions in this Excel sheet. Similarly, you would have to do some functions in the table of SQL to order the table, or else the order of the table would not be relevant, as it would be a like push and pop. Let's say you push this value here, then you entered this value, then you entered this value, then you entered this value. It would just push in the value regardless of the order. Again, going here, tuples may be stored in an arbitrary order, may or may not be. This is, orders of the tuples or the row is irrelevant. No two tuples can be identical. This is an important line, that no two tuples can be identical, because this is an, database sheet. If I have a mistake in my database table, wherein you have this guy, the 7 number, who has every instance, every instance, that is every data that is available in the table for the guy, is which is similar to, let's say where is another Uttar Pradesh, let's say to the third one. This would just mess up our table, and this would just make our table, or the instance, or the relation, inefficient while using it. So we usually delete the tables, or SQL deletes the, instances by itself. Here it is not completely same, but this was a pretty good example to teach you. Keys. Let me skip this part for a few seconds. I would come back to this, because this is more important, and that those are just lines. Those are just, rectification stuff. So procedural, while going through relational query languages, there are two methods of doing this: procedural and declarative. I guess there's a table here. No. These are the two types in which you can, use the relational query languages. The procedural one requires programmer to tell the computer exactly what to do, you know and in declarative, it just requires a more descriptive style. Let me show this. They have provided us with examples. Okay, so procedural one, you should know what you're doing. Let's say you are finding the root of n, so you should know some maths, or some, mathematical formulas to tell the computer, or tell the PC what to do. Guess x naught, then 0 should be tending to I. This formula repeat step 2. Whereas in declarative form, you can just write root of n is m such that n square equals n. Okay, you can see a huge difference. This much complicated stuff you are in 4 lines, versus a single line, which is even easier to read and interpret. That's the basic difference that you must know. relational query languages, pure languages, the languages that are used for research purposes. The above three pure languages are equivalent in computing power. Okay, so relational algebra, tuple relational calculus, and domain relational calculus are equivalent in computing power. I think you would be understanding this at a much higher level when you are actually using DBMS in your work field. We will sorry, we will concentrate on to relational algebra, non-Turing machine equivalent. Not all algorithms can be represent expressed in relational algebra. Okay, so I guess this is pretty much it. Let's go back to keys. Let's go back to keys. So keys are basically tags. If you I think you remember the Python course, wherein they exactly taught you about pointers. What are pointers? They store the data or the location of the data. They store the data about the location of data. They would give you a location where the data is stored in the memory. So let's say, why is this not going away? Okay. Okay, better. K is a super key if R is if value of K sufficiently high. Let's not go here. Let me tell. I have something better for this scenario. This exact scenario. I have this notes that I made once. I am no longer making notes because I am repeating everything again and again through PPTs. So it is basically memorized in my brain. But it is better that you make notes because you are not doing what I am doing. Let's wait a second. I have to check where did I store it. Hmm? Title folder, I guess. No. Okay, so I have this PDF that I have to share. Let me. No, display everything. Let me just hide this because I have to download this from a personal source. And do like, share, and subscribe. Do subscribe to my channel. Hmm. Okay, so I guess the screen is visible again. These were the notes that I made once. Compound key and this. Okay. So basically, it's just what I said. In database, a key is like a tag that makes sure that each piece of information is unique and easy to find. Super key in a DBMS, a super key is like special group of information made up for. See, I will be reading this because this is a pretty good language that I wrote. So uh, I do apologize if what is coming out of my mouth is exactly same as what is shown on the screen because I wrote it from my memory. In DBMS, a super key is like a special group of information made up of different parts like attributes and tuples. It is unique because it is your choice to uh, it is your choice of how you put those parts together. So you can take id, you can take id name, you can take id salary, You can assign any number of super keys as you wish. It is totally upon you. A candidate key, however, they actually help you organize the information. Each candidate key can be identify and specific piece of data in a super special way. So they can only take one at a time. As in foreign key, you could take one or two attributes to assign and take them and assign them as foreign key, whereas in candidate key you cannot do them. You can just take one attribute and assign them as a candidate key. Primary key, any key can be chosen to be a primary key. This is the primary data through which we would identify the other data that is present in the table. So here it is id. Let me show you here. So if I wanted a specific data that represents each and that should be criteria for, that should be the basis for choosing data for each and every one. You can choose any one of these as a primary key. Let's say I want primary key to be, let's say, income group, because in this table there is no ID as such. But let's say I ordered this table and I made this my primary key. Okay, so this is my primary key. Now I want to know the people who come under this criteria. This income slot from 1 lakh to 1.2 lakh. I want just this much data and I can work on this much data. So these are the tuples that I would be working on. Sorry, these are the tuples that I would be working on. And when I make a relation out of this, only this much would appear. This makes the data more workable and makes our work more efficient, because efficiency is what an employer would want in you. Okay, surrogate key. This key gives unique ID to every single data, enables to access a specific data even when the data looks hidden between similar looking entities. Okay, so let's say you want grown up from, let's say you were just provided with these two as a relation. Okay, just this much. And now you have to find the person who is a grown up. Okay, you had to find the age group of the household, that is grown up dominated. So this key, surrogate key, would help you find it easily, because it seems hidden between all of the similar data. If you are not careful enough, you would just scroll through it like this and not see. This is a small table of 100 100 instances, 100 tuples, whereas people or the companies, enterprises, whatever you want to call them, they have data containing millions and millions of people. You use surrogate key efficiently there. You will use a surrogate key many times. Coming to composite key, what is composite key? It consists of more than one attribute to uniquely identify occurrence of the entity. Okay, like first name and you, let's say you were given first name and last name in this table, and you had to uniquely identify the occurrence of that. uh, I do not have a table to show you this. Let's see if they have given us something here about composite key. I don't think it is a part of your syllabus. No, it is a part of your syllabus. Okay, so okay, yes, they have provided us with this table. So how do we use it here? Let's say you had similar names here. Pretty common name is Yash or Rahul. So if many of the people have Rahul as their first name, to identify Rahul Chaube or Lalit Dubey uniquely, you would have been using this composite key. Okay. Now, foreign key values in relation must be appear. Value in one relation must appear in another. Okay, that is simple. Compound key consists of more than one attribute. Uniquely identify this. Blah blah blah. Okay, so let's come. We have basically completed this. And don't ask me for notes. It is some. It is the same stuff provided here. I just wrote it in a more readable way, more readable manner here. Let's go to here. Do subscribe to my channel. This is my channel. I have just uploaded this one video. What is this? I think this was uh, you know trial trial live stream. So this I have already uploaded it, the session for week 1. Do check it out, and let's move further. Choose the appropriate option to fill the blank. The set of allowed values for a given attribute is called the set of allowed value for a given attribute is called domain. choose the appropriate Choose the appropriate option to fill in the blank. Dash is a special value in every domain which indicates the unknown. Okay, that would be null. Which of the following is true about secondary key? Okay, let's go to the keys section. Let's find secondary key. Is there secondary key available here? Okay, so they did not teach secondary key, I guess. No, they did, but they did not explain it here in the slide. Okay. All attribute. Let's skip this much and we'll come back to it. Whenever in exam you find something you're not sure of, skip it and come back to it. You can mark it as purple. I can mark it as purple in my PC when I'm giving examination at the center. Just review later. Just do review later. Which of the following is not a part of pure relational query language? Which is the part not a part of pure relational query language? I guess it is. Linear algebra. It was provided in the last ones. Relational algebra, tuple relational calculus, and domain relational calculus. Only these three. Remember this: relational algebra, tuple relational calculus, and domain relation calculus. Okay, so linear algebra is not a part of it. Okay, so this is the correct answer. What do we mean by domain of an attribute? What do we mean by the domain of an attribute? The set of allowed values for that attribute. You are new. Okay. Hmm. You are new in an IT multinational corporation. Your group lead assigns you a work to you to work on database table. You observe that some entries in the table are duplicate. You can't delete the record, but at the same time you must identify each record so that you decide to add a new column in the table which will work as an auto incrementing serial number. What is the name of solution that you used? Okay. So what we are using is I cannot delete any record, but at the same time you must uniquely identify. Okay, so you decided to add a new column in the table which would work as an auto incrementing serial number. Okay, to you. So basically, we would be using the key that uniquely identifies this. So that is surrogate key, as we just discussed. Surrogate key. Let's quickly go there. Where is surrogate key? Single key, blah blah blah. Surrogate key, unique identifier for either entity in a model. See this, or synthetic key. You can also call it synthetic key. Okay, so my answer is correct. Which of the following key can uniquely identify tuples of a relation? Okay, so that is. Let's find it here. Okay, see, I can do this. You should not. What was it? Super key is to identify unique tuple. Okay, so super key will do that, and I don't think anyone else can uniquely identify the model blah. Let's go with just the super key, and if we get any other, we will remember that. Dash is like a key that uniquely identifies an entity or an object in a database. However, it is not derived from application data. It is not derived from application uniquely identified. It is definitely this surrogate synthetic key, and I guess even the foreign key. And let's move forward. Which of the following option is true for procedural and declarative programming style? In procedural programming style, the programmer specifies how to achieve output. In declarative programming style, the programmer must know specific algorithm to achieve the output. For in declarative programming style, the programmer must know what relationship hold between various entities. This is correct. And relational algebra is an example of declarative. Relational algebra. Relational algebra. Let's check this online. Do we know? I think we have not covered what is relational algebra. It is basically, set relations. They are just the set relations, intersection differences and all. Yes, see this. So I guess this is a type of declarative programming. Choose the correct option. A candidate key is always a super key. Foreign key is a super key is always a candidate key. No. Uh, Foreign key can be a super key. Yes, a primary key is always a super key. So let's see how many blunders did we do. 6.3. Okay, so we are 40% away. So I did wrong completely here. In procedural programming style, the programmer specifies how to achieve an output. Okay, let's check. Let's check. In procedural programming, the programmer knows how to achieve. Okay, so this is, I think by this they mean that this is the specification that we need. And in declarative programming style, the programmer should know the relationship that hold. Okay, so this was correct, but this one. So do remember two lines. Two lines is what we learned from this mistake is relational algebra is not an example of declarative programming style. Relational algebra is not an example. Well, where I thought it was, it is not. And second one is in procedural programming, the programmer specifies how to achieve an output. So this is specification of the program. This is specifying. This is just one liner statement, but this is specification of how to achieve the output. Okay, let's see where else did I okay, surrogate key and synthetic key are the same thing. Foreign key is not the one that uniquely identifies or identifies an entity or an object in database. However, it is not derived from. Okay, these both are the same things. This is pretty much the same thing. See, surrogate key or synthetic key, the terms would be used simultaneously. So I made a mistake here, and remember that uniquely identifying you should not use foreign key. Okay, for uniquely identifying you should not use foreign key. I left out super key, I left out primary key, I left out candidate key. So even primary key and candidate key can uniquely identify tuples of a relation. Okay, so let's go here. Candidate key. Okay, so they are uniquely identifying the tuple that is available, and the primary key. Okay, so yes, primary key is the one you are using for reference, and you are using it to understand the data available in the table, the rest of the data that is available in the table. What did I do wrong here? What is the following to about secondary key? Okay, so all the candidate keys that have not been selected as primary key are called secondary keys. Okay, this is true. All non-candidate keys are secondary keys. This was a big blunder. All attributes are not part of any super key or secondary key. Okay, that is also wrong. Every attribute of a candidate key is a secondary key. Every attribute of a candidate is a secondary key. Okay, that is also wrong. Even that is wrong. So while going into examinations, do remember that this key stuff is to be memorized. The questions on keys are rectification stuff and nothing else. I have not yet used it as I have not yet used it in coding. Uh, on the topic of coding, we would also be covering today these practice questions. We would try to cover the practice questions if we could. Let's go here. So we are moving on to 2.2. Let's remove each and every one of this. This one would basically introduce you to new terminologies that we would be using. Before moving on, let me check whether my voice is clear, whether the stream is going perfectly or not. Okay, so I took pretty long to teach. I took pretty long to cover this one PPT. So let's speed up the pace. Let's increase the pace. Let's increase the pace. But one more thing in D.B.M.S, you are expected to put a few hours, and D.B.M.S usually takes a lot of time to understand. Okay. So the module outline would be to understand relational operations such as select, project, union, difference, intersection, Cartesian product, and natural join, and some of the aggregate operations. I would be, racing my through racing my way through this stuff because this is really, really, really easy. A relation is a set. A relation is a set. Hence, ordering of rows is inconsequential. 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 Okay, a pretty tough word to pronounce. Ordering of rows or tuples is inconsequential. All rows and tuple must be distinct. Okay, so the order is inconsequential. See this a1 a2 a2, but here under the attribute a you are getting a1, then again a2, then again a2, then again a1. So the order is inconsequential. Inconsequential. I cannot pronounce this word. Okay, but tuples must be distinct. Okay, so let's say this tuple is accurately similar to this, and these two tuples are also same. So what would you do? This is not a valid relation. This is not a valid relation. However, this, where each and every tuple occurs only once in the table, and let me repeat this, that a tuple is the entire row. When I say tuple, I am referencing to the entire row. So this is a relation. This is a relation. Uh, Let me check this once. So this is the sign that we use to define a relation. This relation, in this particular relation, we are seeing all of. Okay, what happened? I don't know if you can hear the voice or not. Just give me 1 second. Okay, okay. So there was water leaking. So this relation, this much is a sign of relation. This sigma sign is used for denoting relation. In this particular relation, we are seeing basically two subclauses connected by this intersection. We are checking whether the tuples or the instances available in the attribute A is similar to the instances present in attribute B or not, and also the attributes present in D should be greater than 5. So let's go to the relation. There is no way I can mark or something. I don't know. Let me check. Is there somewhere I can show you or mark you this? Desktop annotate. I think that is the desktop application. I think I have somewhere. Let's write online. If this would be really easy, if I could. Okay, so let's just skip this part. So what do we want in this relation is every attribute, every instance is available in attribute A and B should be same, and the attributes present in the column D should be greater than 5. So this is equal, A and B are equal, and this instance present in the attribute is greater than 5. Okay, 7 is greater than 5. So this would go here. See, this is available. This much is shown in the next tuple. Alpha is not equals to beta, so this would not go. See, alpha beta is not here, it is beta beta. So let's again go here. Now checking beta is equals to beta, so A equals B is satisfied. However, when we go to the D column, we see that it is 3, which is smaller than 5, hence it is not satisfied and will not be available in the resultant table. In the last column, in the last tuple, we are seeing that beta equals beta, that is A equals B is satisfied, and D equals 10, so D is greater than 10, so it is available here. And anything else? So no. So we defined a relation, did some algebra, and this R is just on which table. So every table has a name. Every table is usually called a relation in D.B.M.S. So R is the name of the relation. So let's just call this table. Sometimes you call it instructor, sometimes you call it database, sometimes you call it classroom. It is the name of the table, name of the relation is defined by the user, which this R part would be more and you will understand this part better in the coming lectures. So this is relation R pi. So what pi does, pi removes every pi actually deletes the tuple that are same and uniquely shows us every single tuple that is not repeated. So when I did this relation, when I did pi r over a and c, see, we did pi r over a and c, so it removed, firstly what it did was remove the column b. What it did was remove the column b and give us the column, give us this table. Now what pi does here is pi removes this alpha 1 is repeated, so alpha 1 is removed once. Now union of two relations, so we are provided with two relations, namely r, the name of this table is r and the name of this table is s. So what this will do is this will make the union of two relations. For this to come true, at least one, of the column should be present in both the attribute. If let's say if we have attribute a and b here, but over here we had a and c rather than b, so it would still work. But let's say in the s table, if we had c and d instead of a and b, what would happen would be we would be presented with an error. So what it does is union basically does is it would just add the tuple that is not available in R. Okay, or it would add the tuple from R that is not available in S. Doing going like it's like holding your ear from the front or from the back. So alpha 1 is present here, it was available here. Alpha 2 is present here, it was shown in the table. Beta 1 is present here, it was shown in the table. From coming to S, alpha 2 is available, so it was not appended. Now beta 3 is not available in R, so it was appended in the resultant table. That is represented by this R union S. Set difference, that is removing all the elements present in R that are equal to S. Okay, so let's say alpha 1 is present in R but not in S, so it won't be removed. Alpha 2 is present. Uh, Alpha 2 is present in R and also present in S, so it would be deleted from the resulting table. Now beta 1 is not present in R, is present in R but not present in S, and hence it would be shown in the resultant table. Now if the equation was reversed, right, if the equation was reversed, if it was S and R, if it was S and R, so what would happen is this. Let me just go here, or let me go here, so that I can show you this. Let's call this A, let's call this A and B. We have this resultant table that would come up. Now alpha 2 is, okay, sorry, what happened, okay, alpha 2 is present in S but also in R, so what would happen is it would be removed from the resultant table. And now beta 3 is present in S but not in R, so it would be there. So let me type beta comma 3. This would be our resultant table, this much. If it was the other way around, being S minus R. Yeah, thank God, I just thought that I did not return, I did not, you know, increase the volume. Okay, now let's move on. Let's move on. Intersection of two relation. I think you would understand it pretty easily now. It is basically the set relation that you studied in Maths 1. It would return the common elements or the common tuples between R and S. Okay, so only alpha 2 is present in both R and S and is hence presented in the resultant table, which is this one. This one. Mathematically, you can denote it like this. Mathematically, intersection is denoted by this. This is pretty important to remember. If you don't remember, it won't affect you in the short term, but in the long term, you should remember this formula while using the formula in Python. While you are integrating Python with SQL, you will be requiring this formula. Okay, so what is joining? That is our process. Our process is basically the Cartesian product of this. No, I will need a pen. I will need something to tell you what. I guess there is one way to do this, but I'm not pretty sure how it will work or not. Will it work or not? But let's do this once. Let's give this a try. Because without a pen, my options are pretty much limited. Is there some way I can do it? Is there some way I can do it? Or some way I can just open it. Open it. Oh, let's download the file once. The file is downloaded. It opens as if this now. Let's go to download, show in folder. Let's try to open it. Let's try to open it with choose other apps. Is PowerPoint presentation available? I think PowerPoint presentation would be better to show you. New Microsoft Word, just this once. Just have to find new version. Check the software. Wow, just wow. Okay, open with. So there is no. I will need annotator. go back and let me try to explain this to you. This is easy to explain, but it would be better if I was using a pen. So, see what this would do is take this tuple, put it right here, take this tuple alpha 1, put it right here. Now take the first tuple from S and copy and paste it here. Copy and paste it here. Then it would do it again for the tuples that are left. So it would take alpha 1, connect it with the first tuple and print. It would take the first tuple from R, but the second tuple from S this time, and print it over here. It would take the first tuple from R, the third tuple from S, and print it over here. It would take the first tuple from R, fourth tuple from S, and print it here. Now, since all of the elements in the S is exhausted, it would move over to the second element in R. It would take beta 2, that is the second tuple, connect it with the first tuple, and print it right here. Then again do it for the second one, print it again. It would connect it with the third element, it would connect it with the fourth element, and this is the resultant table that is provided to us. Now, I just showed you how to do it. If the question was given other way around, this question is solved for R cross S. I encourage you to do it for S cross R. Do this question once for S cross R and answer the problem in the comment section. Now, there is also a naming issue. Let's say AB is present in R but also in S. So what the programming, what the program would do is the resultant table would give the B this precursor. What is it called? I don't know. I don't remember. Uh, the word given. It is an English thing. Giving the name to something that is that comes before a word and after a word, predecessor or something. But for the basic point, to distinguish between the two B's, because while in Cartesian product it goes to each and every one of this, each tuple is connected to every other tuple. So to distinguish the tuple or the attribute present in R table, it is written as R dot B, and the tuple present in S table, it is written as S dot B. Renaming a table, okay. Composition of operations. Okay, so again, let's say you are working on a table, you are provided with the table, and what you want here is you want an output where all of the elements in column A are equal to column C, while you have already done R process, right? So let's say you were given two tables R and S here. You are provided with the two different tables R and S here. What you do is first make the Cartesian product between these two, okay, and now separate out. Is this? Yes, this is the same, but ABC. Yes. You make the Cartesian product once, and then separate out each and every tuple where A equals B. So this one would come out. First one would come out. Second won't. Third won't. Fourth won't. Fifth won't. Sixth would, and seventh would. There would be three elements in this table. So let's check. Let's check. Okay. Are there three elements in this table? Yes. There are only three elements in this table. Three tuples in this table. Now let's go to join. What is joining? What is joining? This is the symbol for natural join. Do remember this. There are various way of joining. There are various methods of joining. But do remember that this is the symbol for natural join. What is joining? So okay, joining two relations. They have not defined what joining is yet, but they surely have defined natural join. Okay. The natural join of a relation S and R in the relation is a relation on schema R union S obtained as follows. Okay, let me teach you this. Let's not go confuse ourselves with the words. What this would do is alpha 1 alpha, alpha 1 alpha. It would okay. So what happens here is it checks both the tables for common attributes. So B is common here, and B and D are common in both the tables. And since B and D are common in both the tables, what this would do is this would give a give out the values wherein B and D are equal. Okay, all the tuples wherein B and D are equal, and then do a Cartesian product on them. I really need this. I really need this. So let me. I'm sorry if I'm taking a few minutes. I have to do this. I have to figure this out. Without pen, I won't be able to tell you what to do. So let's take a break for a few minutes, and you can skip the video till then. I would be taking a few minutes now. I really need to figure out how to use pen, because without annotation, I won't be able to tell you. Okay. I think it would take around 5 minutes. Skip the video till past. Skip the video for 5 minutes. Okay. See you soon. So I'm actually, I apologize that I still could not find a solution to the problem. Let me tell you one thing, that surely do not do this. Never use this epic pen. These people are just a bunch of frauds. I tried to do this. I tried to use it. It made me download it. Wow, I stand corrected. These people are not fraud. I'm sorry. Okay, so let's start. These are pretty good people. Okay, but the color options available are limited. Let's start. Let's check whether my voice is available. Okay, I am audible. I am audible. So let's start. What natural join does is, so we were at natural join. What natural join does is, firstly it checks which of the attributes are common in both the tables. So let's take this. So the attributes B and the attributes D are common in both the tables, right? These are common in both the tables. Now, what it does is once it finds that there are common attributes between them, what it does is check both, take a singular tuples. Let me remove all of this. Checks the tuples, removing this. Okay, so let's remove this. You do not want to work with this right now. Okay, this is useless stuff. Now what it does is, it checks which one of the following tuples are common in both. So we have 1a here, we also have 1a here in table B. Okay, again, is there 1a in table R? Okay, we have another 1a, and we have 1a here. Okay, so there are four instances of, there are four instances where 1a occur in both the table. So what it would do is take the entire tuple, right? For take the entire tuple, take these entire tuples. Let me, I think I should use another color, right? Take the entire tuple. Okay, there are other color palettes. What it would do is take the entire tuple, take this entire tuple, take this entire tuple, and take this entire tuple, right? Now take these four tuples and make Cartesian product with this, right? Including the, this pink part. They would also use the data from in the pink part. So I use this table. Now what I would do is make Cartesian product between these elements. Okay, these tuple elements. So the first Cartesian product would be this, right? Taking this, the first element from R, and then connecting it to S, then taking the cell. Okay, and it is available here, right? You can see it right here. Let me erase this. Okay, let me erase this so it is, visible properly. Let me remove this blue part and this blue part. Okay, so it for the first thing it checks is common attributes. Then it checks whether they have common tuples. Once it finds those common tuples, it takes the entire row, the entire tuple, and makes these Cartesian product with it. Make this Cartesian product with this. Let me connect this, even this, so that you understand it better. And this, right? As you can see, it is present here this much, right? It is covering the second part. See, now again, it checks. See, we are left with the element, a tuple. So there, which is two, and which is B. So two. Okay, here it is, two B, which is common here. It would take the entire row. It would take the entire row. Now, once it is done, let me explain this to you. Once it is done with 1a, the Cartesian product would be only made between the common elements. Okay, so it won't occur that the 1a would go to this 2b. 1a won't make Cartesian product with 2b. the Cartesian product is always made between the common elements in the tuple. So let's remove everything. Coming back to this, coming back to the color palette, uh, which is this 2b, okay, this much, and 2b here, and make a Cartesian product. It is a singular line that is present here, because there is no other line that is, there is no other row that is present in either of the table. So I guess you understood what this thing was. Let me go back to the pointer. Let's move on. I would explain this again later on, because I guess when I complete the slide, because there is a lot of confusion in your mind, and I get that, because we did not have pen. If you want, I would be explaining this in another video. I would be making a specific video, a short for this. Okay, this that would be my first time making a short, but that I would make a short on this. Okay, so what are aggregate operators? What are aggregate operators? I don't have pen, right? I will buy a writing pad. These are aggregate operators, that is sum, average, max, min, etc. Let's, okay, so this is stuck here. This is not annotating on the PDF itself, it is annotating on the desktop. It is annotating on the desktop. Just remember that you just need to remember this much and nothing else. Now, this is an important table. Read it, understand it, and remember the words. Okay, remember these words. It is important that you understand and remember these notations that are used along with the terminology. So let's see if I call this a selection, that is represented by sigma. Pi is representing projection. Now these are easy thing, and this infinity looking symbol is representing natural join. Let's move forward. Let's move forward. I would be explaining, I think I will explain this to you once more. Okay, let's explain the natural join once more. Okay, there are basically three steps in natural join. The first step is identifying the common columns, that is these standing lines. Let's identify the common columns, right? Let's identify the common columns. I guess this one would be better. No? What was the one that I used? I guess I used this and this, I guess. No, I don't know which one I used. I just used it right here, right? Okay. So let's focus here and not waste our time on this. Okay. So what it does is it basically separates out the common columns. So the common column available here is this B1, and then this D1 in both the tables. Now it uses that data. Finds out the common tuple between them. The common tuple between them The common tuples would be this, not the entire tuple, just the elements. Okay, comparing the common elements in the B and D column. So one A, one A, one A, one A, again one A, one A, over here 1a. The first step completed that common column selected, second step completed that common tuples in that specific columns chosen. Now the third step is doing Cartesian product. We did Cartesian product and this comes out to be the answer. The fourth step is moving on, repeating the repeating the second step. Fourth step is repeating the second step again. So again finding common elements. So 2b is common in both. 2b is common, taking 2b, making Cartesian product between 2b and projecting it in this final table. Okay. Yes. So it is a bit irritating stuff. Let's do the exercises and take a break for I guess 15 to 20 minutes. I guess 10 minutes would be enough. 10 minutes break would be enough. I need a break for my throat. It's been already 1.5 hours, so adding 10 minutes to it, I think I would be removing. I would have to remove the parts or the gaps between the video. Okay, so let's start with activity questions. Which of the following is not an aggregate operation? Which of the following is not an aggregate operation? Mhm. That is, let's see. Sum is, average is, max is, min is. Sum. Okay, so prod is no. There is no such thing as prod operation. Consider the given relation. Okay, we are given with the relation. What will be the final output of the following relation? So, what we are doing is we have been given with two if and buts, two conditions, and first we need to evaluate the conditions individually and then do a union over this. Okay, do a union over this. So let's go to the table R and find where all a equals b. Okay, so a equals b. The the first column would come. The first column would come. The third column would come. Now the second condition is c should be greater than 2, right? So c should be greater than 2, not equal to 2 but greater than 2. So once I look, it is clearly visible that in this case c is equal to 2 and not greater than 2. So we would be eliminating this tuple, and our final product would be the final answer would be this much. Okay, let's check. That is A B C D 1134. Okay, A B C D 1134. A B C D 1134. A B C D 1134. Okay, so we need a union over that. Na, we need a union over that. A equals B. A should be equals B, and C is greater than 2, and C is greater than 2. So there, that is where I made a mistake. It is union and not intersection. So this won't be of any use. Let's remove this. We would be considering both the tuples as it is union and not intersection. Had it been intersection, we would have eliminated this part. So it would be ABCD 1134 and 1123. ABCD 1134 and 1123. Okay, we have already selected that. Is there anything else? No. So let's move on to the question number 3. Again the same relation, but pi ADR. The following, okay, so the question is, let me zoom out. how many rows, that is how many tuples would be there in the output of the following relation. That is pi projecting columns A and D, projecting columns A and column D. Now to what was this? I'm sorry. I guess the shortcuts don't work. Control Shift 3. I pressed Control Shift 3. Control Shift 2. Okay. Control Shift 2. 3. Control Shift 3. Control Shift 2. Okay. So the upper words work. Okay. So we would be projecting it as this. See, projection of the column A and projection of column D. Now, how many tuples are there? One, two, three, four. So there would be four tuple in the resultant output. There would be four tuple in the resultant output. Let's move further. How many rows will be in the union of the above relation? That is troublesome work, but we would be doing it. Okay. So in the union, if there is a row that is not present in both the that is if there is a attribute that is not common in both the tables, what it would do is it would leave null spaces for the empty data that is not present in the either of the table. So if I do union over this would just take this part and attach it here. Okay, it would take the table and attach it here, but we would be left with what we would be left with is this much part, which would be empty, containing null spaces, right? Let me bring this here. This would be easier to do it from here. The table would attach itself here, add itself here, but this much would be the spaces or the cells having null value. So let's do this. Let's start checking our answer. 090, is there something as 090? No. 222, nothing. 111, nothing. So both of them have unique values for the attributes A, B, and C. For the attributes A, B, and C, both the tables have unique tuples. So what this would do is this would just come on top of this, or this would just join itself below this, but the final table that comes out would be 1 2 3 4 5 6 sorry, my mistake. Let's do 4 5 6 and 7. It would be 7 tuple long. Okay, it would be 7 tuple long. Let's remove all of this and move further. Consider the two relations R and S. Okay, we are provided with two relations. Okay, in how many rows will be there in the union of the above two relation? Okay. So while uniting these two, uh, R in all the three have, okay, integer. Every value in R is a integer, whereas in S the B column is a varchar type thing. Okay, so it is a varchar type thing. How many values will it have? How many values will it have? So let's check. Is the union possible for this? Is the union possible for this? We would have to check the PPT for this. And now let's go to the union part. Okay, so this is hit and try thing. I think union is not possible. If it is possible, I will find a way to explain this to you. I have two theories. If it is possible, it would be uh, easy to explain. If it is not, then my answer is correct. Let's move further. consider the two relations. Okay, how many columns will be there in the Cartesian product of the above relations? Okay, what Cartesian product does is take this, this, and this, something like this, right? It makes Cartesian product like this. And how does it do it? It will make a new table containing the Cartesian product with something like this. A. So let's firstly focus on how many rows will be there. How many rows will be there? So I think it will have 3 times 3, that is 9 rows. But how many columns? That is a good question. That how many columns will the following one have? Because according to the naming stuff that is provided, the data that is the data that is provided in on renaming the table, it should be 4 if two of them have same stuff. If two of them have same stuff, it would be okay. But the Cartesian product, while doing it, has unique one, right? This one has unique AB and this one has unique CDE, whereas here it is common. So what it would do, what will it do? What it will do is, since it is common, it will make it like this. Okay, it will make 6 columns. 6 columns, that is true, it will make 6 columns. And how will it make 6 columns? Let me explain. Here would be the A from relation R. Here would be A from relation S. Here would be B from relation R. Here would be B from relation S. Here would be C from relation R, and here would be C from relation S. Now, the naming would be as follows. The naming would be RA, SA, RB, SB, RC, and SC. I think you understand what I am trying to say. And what was this? I think let's clear the screen and let's move forward. If relations are not union compatible, which of the following operations can be performed? Okay, if they are not union compatible, I think Cartesian product can be performed, and intersection can be performed. Intersection can also be performed as the non-common values or non-available values would be set as null. We are again provided with two different tables, that is R and S. How many rows will be selected by operation R? Okay, so we want natural join between R and S. Okay, this is good. This is something practical that we would do. How many rows? Okay, so how many tuples? Firstly, let's find out the common columns. The common columns are A and let me do this. Okay, the common columns are A and C, right? The common columns are A and C. Now, let's check the tuples. So for this, I need to remove this, and I need to remove this for the time being. And let's check the common tuples between them. So checking out the common tuples would be an easy task. A1 C1, it is present here. So okay, A1 C1, is A1 C1 present somewhere here? Anywhere here? A1 C2, A1. Okay, so it is not. A2 C1, A2 C1, nope. A2 C1, no. A3 C3, A3 C3 is present somewhere else? No. Okay. Now, I think this would be better, right? I think this would be better to color code it. A3C3 should be color coded, right? Because you can only make Cartesian product between the same elements, and not this. You cannot make Cartesian product between the yellow and the blue one. You can only make Cartesian product between yellow and yellow. So let's say if there was another yellow line here, you would have made Cartesian product between this one and these two. Okay. Okay, A1 C2, A1 C2, is A1 C2 present here? Let's check. A1 C2, Okay, A1 C2. It was A1 C1, right? We want A1 C2. Uh, okay, A1 C1 is done. Now what we want is A1 C2, A1 C2, A1 C2. Okay, so we have A1 C2 and A1 C2 present here. Okay, nowhere else. And the final one would be A2 C A2 C2, right? A2 and C2. So for our question, what we need is the Cartesian product of the respective colors, right? The Cartesian product of entire tuples, right? Cartesian product of the entire tuple. So while making Cartesian product between yellow and yellow, what I would be doing is, taking the entire tuple, these entire tuple, and making Cartesian product between them. Taking this entire tuple and making Cartesian product between them, right? I think you understand. So let's not make the table itself, because our question rudimentally focuses on the number of rows. So since there are unique numbers, right, there are unique four colors that are present here, that is yellow, blue, pink, and orangish brown, I guess. There would be four Cartesian product elements, that is the number of rows would be 4. The number of rows would be 4. Okay, now consider the relation SABC and RPQC, okay, such that the relation S has 30 rows, S has 30 rows, and R has 12 rows. Okay, what is the maximum number of rows that are possible in R natural join S? Okay, so we have, let's do this. Let's remove all. We have a table S, and we have a table Y, R, sorry, a table R. Let's do this. Since we are only focusing on the common stuff, it has three attributes, A, B, and C, and this one also has three attributes, P, Q, and C. But we are rudimentarily focusing on the common one, that is this one, right? The C one, right? We are just focusing on the C one, so let's remove all of this. Let's remove all of this. Now, what is the maximum number of rows that are possible in our process, right? So there are 30 rows. There are so I cannot do this. Okay, no issues, no worries. So there are 30 available in S and 12 available in here, right? In the P1. So what are the maximum number of rows? So let's say each, in the previous question there weren't any unique tuples present, but let's say every tuple present here is unique. Every tuple present here is unique. So how will you make the Cartesian product? You take Cartesian product between uh, the same element, the same color coded tuples, right? So let's say there was a column here, and you made Cartesian product with all of this, right? All the 12 elements present in this table. I won't be making but all of the lines, but you get the idea. So I took the first tuple and made the Cartesian product with all the elements in the other table. Now what I do is now what I do is take the second element here and make Cartesian product between all the elements. So I did it once. That was 12 elements that came out. I did it 12 times. For the second time, I am again doing it 12 times. Okay. So let's say I have a third one, and I do the same stuff for it the third time. I do the same for the fourth time, and up till the 30th time. Okay, I'm making relations 30 times. That means I would be making the number of tuples which is equals to 20. 20 times 30, 20x 30. Okay, there is only I can only write two things, right? 20x 20 times 30, right? That's what we need. So the total number of tuples is 600, right? The total number of tuples that would be present, the maximum number of tuples that would be present are 600. Consider two relations A, B, C and P, Q, C, 30, 12, the same. The minimum number of rows, okay. So the minimum number of rows, this is why I did not remove all of this. Let's say the minimum number of rows would be the minimum number of rows would be 30. I guess it would be 30. Let's see. Is either it's see once doing it, let's check which one would be. It would be either 30 or it would be either 12. Okay, okay, or it could be the zero, that there are no common elements. Okay, there are when there are no common elements in the table. Let's say if you go to this table, we had this, a1 c1 and a1 c1 present here, but there is, let's say there are no common elements. You took each and every element here and each and every element here, and you found no common no common elements between them. You can simply write zero. Okay, yes. Okay, I got pretty bad marks in this, but let's check where did we go wrong, and let's see what is the matter with this. What is, why is it getting 360? Let's go and start from the top. Okay, okay. The consider relation. Okay, how is it 3? How many rows will be there in the output of the following relation operation or on R? Okay, how many rows will be there in the output of the following relational operation on R? Choosing A and D. A and D. Okay, so what this is doing is, this is removing. Projection always removes. Okay, let's read the slide once and properly this time. I don't know where slide go. See, we have this right on the last page. It is given to us that see, in projection, remove all duplicate tuples from the output. So we did not take that into the into consideration, that it would remove all the common tuples. So while projecting the columns A and D, the 3131 column that is common in both is removed while projecting. So okay, here's, it is wrong. Uh, One mistake we learned, the thing that we learned from our mistake is, always remove the common tuples while doing projection. What is wrong in this one? How many rows will be there in the union of the above two relations? How many rows will be there in the union of above two relations? Okay, as I said, union is not possible. As I just said, that union was not possible because the data type is different. Okay, wait a second. Nope, 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 nope. Okay, union is not possible in this one, even in this one. So here the union is not possible. Why? Okay, so the union, the best idea that I can get is, the number of attributes or the number of the columns are not equal. This is the best explanation that I can give right now. Is that if the number of uh, attributes present in relation R is not equals to S, the union won't be possible. Okay, it usually leaves the other spaces null, but since this is what the output requires, let's go with this. It would usually give you null value, but since it is provided that union is not possible, let's go with the answer that they provide. They are better at what they do than me. Okay, this is correct, this is correct. Union should come. Okay. If two relation are not union compatible, then which of the following cannot be performed? Okay, cannot be performed. I made a mistake here. Okay, so set differences cannot be performed. Even intersection cannot be performed. So even in that section, intersection could not have been performed. Okay, this was right. This was right all along. What is the maximum number of that can be made? Okay, what is the maximum that can be made for common? Okay, so I did what I did here was wrong. It is actually 12 times 30 and not 20 times 30. It is 12 times 30, right? So 12 times 30 is 360, the maximum number of rows that is available. That was a silly mistake, and even and here it was a logical mistake. That what if I did not take into consideration whether and when there are no common elements between them. Okay, so what we learned through this one is that always take care that projection would remove the common elements. Secondly, we learned that if there are if the number of columns between the two relation is not similar, then the union won't be possible, and the union will not be possible even when both the data types are not equal. If they are equal but the data types is different, then the union is again not possible. Let's go to the end. This was a calculation error, and we learned that if there are no elements common between them, then there would be zero number of tuples present in the natural join. Okay, so what I'm saying is, let's take a break of 10 to 15 minutes. Let's put the timer. I'll be putting 15 minutes as a timer. Let's see you in 15 minutes. You can skip to 15 minutes later. Okay. Okay, so it's been 15 minutes and we are back. What I have planned in the, what I've seen in this 15 minutes was, let's not do the, practice questions that are given. I would be making a separate video or separate live stream for that. The reason for this is simple yet challenging, that we are currently focusing on quiz 1, quiz 2, or end term type examinations, and and in that practice problems, they are more oriented problems. So let's just focus on completing till practice assignment, as that would be the most the time would allow us to do. Okay, so let's go here. Is my screen visible? No, the screen is not visible. Okay, the screen is visible to you guys again. Let's go here. Let's see this. Let's remove this. Introduction to SQL. Okay, let DDL drop. Let's remove all of this. Let's remove all of this. Let's put it at 1. I wish there was a way to remove all of this, as the first 4 are 1 1 1 1 1, so it would be really hard for me to forget, and it would be just in my side muscle memory, brain muscle memory, or somewhere. Let's start what we were doing, and do this. Where is the PPT? Where is this PPT? Here is the PPT. How many pages are there in the PPT? Let's check. Is the brightness appropriate? I think the brightness is low. Is there some way I can increase the brightness? Let's check. I don't want to download you, man. Okay, let's go through this. Okay, history of SQL. IBM developed structured English query language SQL. We saw it at the beginning of this session. ANSI and ISO standard SQL. Okay, in 86 it was formalized. In 89 integrity constraints were added. 92 major revision, de facto industry standards. Just read this once. It would be useless to just repeat what's written here. Read this, pause the video and read this. There are many alternatives, but you do not use those much. SparkQL, pronounced as Sparkle, is a recursive acronym of Sparkle Protocol and RDF query language. Is an RDF query language. Wow. A semantic query language for database able to retrieve, manipulate data stored in resource descriptive framework. Let's search this. What is resource descriptive phase framework? Remove. Control V. It is a family of W3C consortium. Specification originally designed as a metadata data model. Okay, metadata data model. What is it? Self-describing, a framework for describing resources. Okay, we had Sparkle 1 in 2008, and the first update that ever came was 5 years later. Pretty slow, people. Data definition language allows the specification of information about relation, so basically used while forming the data, right? Types of domain, this is important. Okay, learn this by heart. Char. Okay, these are the data types, these are the domain names. So let me show you in this table. So every attribute has a data type that is allowed in the column, right? So this has character, this has character, this is varchar, variable character. This has this again has varchar or numeric, but this is varchar. This is numeric. So let's go. Char fixed length character strength with the user specified length. Okay, user would be specifying how much the length of the characters that can fit in a particular cell should be. Variable character strings, like this actually allows us to use the special symbols such as and, at, hash, dollar, etc. Int is basically integer. Small int, a machine dependent subset of integer. Numeric. Numeric is a fixed point number. That means if I introduce numeric 3 4, sorry, 3 comma 1, it allows me to write the length. The first one describes the length of the number, that is 3 units, and the second one defines where this decimal should be. It should be one places after the zero, the zeroth place and the first place. It should be one slot after the zeroth space. So let's say we have read this line, it is self-explanatory. Real double precision, floating point data. Okay, floating point number, use a specified precision of at least n digits. Okay. Schema for university database, this is just an example that they gave us. Okay, let's create a table. The create table command. This is how you would create a table. Create table instructor id, where the id has the maximum, the domain of id is character with maximum length of 5. The domain of name is varchar with maximum allowed limit of 20. Again, the same for department name. And for salary, it is numeric. That is, you can have maximum 8 characters with decimal at 2 places from the zeroth. Okay, that is at the 10th place. There are some integrity constraints. Okay, primary key declaration on attributive or on an attribute automatically ensures not null. Okay, so this what this line means is a primary key cannot be null. A primary key cannot be null. It must have data in it. Data should be present in the primary key. Okay, more examples. So now let's use the DML, data manipulation language, and manipulate or change the tables, change the data in the table. So the first one is updation, that is insert into instructor value, that is inserting. This is a command. This is name of the relation. Just before we saw table R, table S. So this is table instructor. So we are inserting into this table and we are inserting the values, these. So let's say, let me do this. Okay. So let's say our table has here, it is quite big, right? It is quite big. So let's say our table has this A, this would go in B, this would go in C column, and this would go in the Dth column, right? That's how this would work. That's how you enter data into the table. Now, let's say we want to remove each and every tuple from the student relation. We would write delete from student, student being the name of the table. So let's say if the name of this table student, I won't be writing student. I would be just writing std, stu. Okay, stu. If this was student table, it would remove every single one. It would remove. every single one of this, right? From this table, delete would remove every single tuple. Every single tuple would be removed. Dropping the table would mean deleting the table. So let's say I drop table R or I drop table student. The whole table would be deleted. So let's say the deleting tuples and deleting table are two different things. Let's say I delete each and every tuple, right? Control and I delete, okay, every single one of this. Okay, I delete it, right? Yet I have the attributes present. That is called deleting. However, dropping the table would mean deleting the entire sheet. So this sheet is called dataset 3.678. Dropping the table would mean deleting the entire data sheet, dataset underscore 3 underscore 678. Alter table R, add this, drop a. Dropping of attribute is not available to all of the databases. However, you can also drop a singular column from the table. Let's say you want to remove this whole column, you can just write drop a from students, right? Drop table or alter table R, drop a. Okay, that is a way of writing the query. Data manipulation language, query structure. So the base typical query structure is this: select. So you are selecting attributes along with the data present in it. So you are selecting the whole column. Let's say you are selecting column A, B, C. So the structure of the way of writing the program would be: firstly you would select the columns. Now you tell the program from where. Okay, so from which tables do you want the tables to be from? So let's say I want to select names and dates from two tables: students and instructor. Now where is if clause? Okay, where is if clause of Python? Where is some condition? P is some condition that has to be, satisfied for the tuple or the column or both in some cases to be shown in the answer table or the resultant table. So what did we learn from here? That there are three parts: select, from, and where. You would firstly select attributes from some specific table and then define some specific P predicate. Select clause. The select clause. Okay, so now what we are doing is we are explaining each and every one of it. Mm-hmm. Okay, so this is just explaining each and every single one of this. Let me explain what this is. The select clause lists the attributes desired in the result of a query. Okay. Example would be selecting name from the instructor table. Okay. uh, SQL names are case insensitive, so writing in whatever, you can write name, you can write whole capital, you can write it as whole small. It wouldn't matter, it would still fetch the same attribute. This is the thing to remember, that SQL names are case insensitive. SQL allows duplicates in relation as well as in query. So while selecting, okay, so we are introduced with two different sub part of select clause. You can use distinct to remove any tuple that is repeated, any row that is repeated. So this would take all the attributes, all the tuples in the attribute department name, but distinct ensures that the repetition is not done, repetition is not allowed. Whereas if you want the repetitions to be there in the resultant table, you use all. Two simple different things, and your table is entirely dependent on this. Select distinct and select all. Distinct ensure no repetitions, whereas all allows repetitions or duplicates. In questions, the word duplicates would be used. Asterisks means select all, right? Denote select all from instructor. That is, it would be selecting each and every attribute. Let's say I wrote select all for this table, right? So what it would do is it would select every single attribute from this along with the data, along with their data. Okay. For this, I would have to write select star from dataset underscore 3 underscore 678. Okay. Mm-hmm. Okay, let's go further. Okay, so it can the select clause can also have arithmetic operations such as addition, subtraction, multiplication, and division in it. So let in this query we selected ID, name, and salary divided by 12. So let's say our salary was for a particular person was available uh, on an yearly basis. The salary in the table was for yearly basis. Now the salary that is presented in the table is on monthly basis, right? The monthly salary. Let's move further. Where clause specifies condition that the result must satisfy. Okay. So okay, I think from should be taught first, right? From clause lists the relation involved in the query, or it basically tells which tables are included in the query, right? So whenever we write from, either it should be one. So let's say if we only use the instructor part, right? The only instructor part, it would be using all the attributes from instructor part. Now let's say we only use teaches part, it would be using all the attributes from teaches part. But what is the meaning of this instructor comma teaches? What this specific query or this specific from clause does is take the instructor table, take the teachers table, and make a Cartesian product of both, and use the resultant table as the basis for this select clause. Okay, so let's say we were given with the table R and we were given with table S. So the column selected would be from the table R cross S. Okay, let's now tell what where clause is. It basically specifies the condition that results must satisfy. So we are selecting name attribute from instructor table, where department name is computer science. So every tuple should satisfy this specific condition P, that is department name is computer science, or we can also use department name is computer science and salary is greater than 80,000. That is where clause for you. Comparison can be applied to result of arithmetic operations. Okay, let's quickly solve this. Where is it? So come on, we know that first four were we remember that first four were first, so there is no meaning in telling you that, but still, which of the following commands set the domain for the values of attribute? Okay, domain sets the domain. Okay, that is explaining what the domain of the schema is, and which of these will on schema, that is data definition language. The command This command is used for removing records present in a table. So delete is used for removing records present in a table, right? Not the whole table, not the whole column, but the specific instance that is present. Which of the following command can remove the entire table structure along with its records? The drop command. If you want to add new column, in an already existing table, which set of commands would you use? That would be alter and add. We are not taught modify, we have not been taught create, append, and all this. So by elimination this would be your answer, but to explain this, just refer the PPT once. It is shown right here. Remember this: alter clause, alter and add, alter and drop. In the sequel, the select command performs which equivalent in relational algebra operation. The select command actually displays, not selects, but displays. I may be wrong here. Okay, I'm not some guru. I may be wrong here. Consider the given query. Select data science as department from employees. Which one of the following describes the operation performed by this query? Okay, we are selecting data science as a department from employees. Displays table with one column named department and as many rows as the number of employees. So what this would do is search in the table all the employees that have data science as their field and change the name of the attribute in the resultant table to department. Okay, so let's say A was the resultant attribute that should come. Okay, so let's say A, the attribute that must come or that should have come was A. Okay, but what this would do it, this would change it to department. Okay, this would change the name of the attribute to department. I think it is pretty easy to understand. And this will consider all the rows as the number of employees with the value data science in each of the rows. Okay, consider the given query. Select the employee name and salary should be 1.5 times as bonus from employees. Okay, displays so we have we have two attributes. One is salary times 1.25 and one is employee name. So what it would do is it would display two columns as bonus name with employee name and bonus, because salary is used as bonus. Okay, so what this would do is when we use as clause, this only denotes this only changes as clause only assigns the attribute name with which it is used. Okay, so if as clause was used with employee, it would have assigned employee name a new name that is bonus, but since it is not, it is used only with salary, it is only assigning salary the new name bonus. The value of bonus column is 25% more. Okay, yes, this is correct. Multiplying, that is, this is some mathematical stuff. When you multiply 1 point something with 1.25, the value of let's say you multiply x with 1.25, the value of x increases by 25%. Consider the given query. Select employee name from employees. Select employee name from employees where salary is salary times 2. Okay, I think the first query will display name of all the employees, display name of those whose new salary is twice as that of new. I think this is the answer. I will come back to the question 8 later on. So choose all the correct option from the given below choices. Foreign key can be primary key. Yes, a primary key should be always unique, should always not be null. Table may not have any primary key. Note this. I don't know about this. Should be unique. Yes, it should always be unique. Choose all the errors if any in the given. Okay, so it's either okay. The word table is from create table employees, right? It should be create table employees. It is always create table employees, right? Create table, create table, create table, create table. Okay, so the word table is missing. Secondly, Okay, so now these are line 1 and 2. Primary key. Okay, primary key is wrong. I think only one error is there. Let's see how many. Okay, this is a pretty good score. This is a pretty good score. Let me do, go to top and remove all the errors. Okay, so select clause does not do display, it does projection. Okay, so select clause does projection. That is good. Now, eighth one is it displays the name of all the employees, and Q displays nothing unless salary is zero. Okay, yes, the Q will display nothing because once salary is defined, you cannot, and you are not changing the value of the data. So let's say your salary is 1,000, and you again go through the entire table checking whether the your salary becomes suddenly 2,000. That is not possible. Whereas if your salary is zero, your salary times 2 is also 0. So okay, so this is correct. A table may not have a primary key at all. Okay, and a foreign key should not always be unique. Okay, a foreign key cannot be unique. Let's see. 10 on 10. Good. Three mistakes we discovered here. Select command project user, does projection. Select command does projection. Then let's go down, 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 down. A table may not have a primary key. Foreign key cannot be unique. And just okay, we are completed. We are 2.5 hours into the session. Okay, okay. So this will take, I guess, another hour. I think it will take another hour now. We are 2 hours and 35 minutes. Let's start a timer of 3 minutes. My throat is hurting. And after that, the timer would be of 1 hour, and I would be trying to complete the session in 1 hour itself. Okay, let's wait. I think there is some issue still going on. I need a few more minutes. Let me resolve it, and I would be back. If you are watching this video later on, you can just skip to the part where the screen is not black. So we are back. I hope it was easy for you to find the non-blank part. Let's start. Removed all of this, right? I will edit out. Don't worry if I this is not a long video. If you think the problem here is the connectivity and some personal issues that I'm facing here, I heartily apologize making this video this long. Okay, so let's go through this once. Additional basic operations, Cartesian product. Okay, I told you how we do Cartesian product. So there are instructor, there is teachers, two different tables, and this in between is the Cartesian product. Okay, examples. Okay. Rename as operation. We saw renaming of the operation. So let's say I select okay, as renames a given query to the given name that we wanted. So we are renaming instructor as T, we are renaming instructor as S. Okay, so what does this mean? Does will it make instructor T and then override it with S? No. This means that T is also containing instructor table and S is also containing instructor table. Okay, then why is it necessary? Explained right below. Okay, we want all of all of those distinct names from the T table where the salary is greater than other people. This and the department name is computer science. So let's say find the supervisor of Bob. It is Alice. Find the supervisor of the supervisor of Bob. Okay, I think David. So is David. Find all the supervisors, direct and indirect of Bob. So what this would mean is Bob has supervisor Alice, Alice has supervisor David, David has Mary, Mary has Susan, and hence the iteration stops here. String operations. Okay, this is important. This is important. It takes time to understand, but once you do, it is piece of cake. Okay. SQL include while checking through string, let's say you want to find this word. Okay, dar. How many of the words in a given table contains the letters DAR in the given order? So what you would do is you would add this percentage marks on both the sides of dar and check whether it exists in the string or not. Okay, is my voice did I start my voice? I have to check it constantly. So is it present in the string or not? Okay, so darshan, there is dar in that. There is damodar, then there is samundar, there is uh, chadar, samandar. I guess you get the point. It does not care where in the string it is located. It just checks whether these three words are there and in the given order and together in the string. Okay. The backslash is used as an escape character, as you can see here. Now patterns. Okay, so now this was just a basic operation. This is a little higher. This is a bit on the higher end. Okay, so a percentage behind a given query means it would match any string beginning with intro. Okay. So let's say this is our whole string. It would check the whole string even if intro was present anywhere here except the prime position that is before pattern. It would not accept it. It would not accept it. So let's say this is our string. Yet still the word intro should be over here. Let's say this is our string. Again the word intro should be here. Okay. I think you understand what I'm trying to say. It should be at the beginning and not at the end. And again, between the two, it would mean it would check entire string and check whether comp is present anywhere in the given format uh, in the string. Okay. Now, what this does is matches, between the apostrophe, between the exclamation apostrophe. What this does is checks the string containing exactly three characters. If there were four underscores here, it would check for four characters. If there were two, it would check for two. If there were five, it would check for five. Okay. Now this string, this checks the string must at least contain three characters. Okay. The This is like a pointer. Okay. This percentage sign is like a pointer. So we kept the pointer here. This means that we don't care if the string is greater than 3. Okay. We would be including it in the the resultant table. But if it is lesser than 3, not even equal to, if it is less than 3, we would remove it from the resultant table. SQL supports variety of string operation, concatenation, converting upper to lower, finding string length, extracting substring, etc. Okay. List is alphabetic order. Okay, 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 okay. Order by. So we are now ordering the display of tuple. For prior to this, I told you that order is irrelevant and the table would be represented as is. But now let's say we need the table ordered in a specific way. So what this specific query does is orders the given table by, let's say, order by name. Here it is order by name. So we are ordering the table keeping the name attribute in mind. Let's say we took salary. Let's go to this. Let's income group, right? If I would, if I wanted to, change or order the whole column using the income group attribute, I would be okay. Where did it go? I would be setting it. I showed you how to change. Whenever whenever ordering, you should know that the order would be by default in ascending order. However, if you want the order to be in descending order, you should add desk after the query. So if you wanted the name to be ordered in a descending way, you would be adding desc over here after name. Now selecting the number of tuples. Okay, fetch first 10 rows. Okay, what this query would do is only fetch the given. Okay, okay, okay. So what this fetch program does is fetches a specific number or specific tuples from the beginning or from the end, or between the 2 points that could be mentioned in between. Where clause, okay, you need to understand between. So where salary is between, just give me a second. So what that disturbance was is I have relatives, I have guests at my home. Let me go through this quickly. What between operator does is compares a given query between two given situations. Okay, come on, what is wrong? Okay, you can also compare it by the tuple way, comparing a given id, a given attribute with the other, like this. Now in operator, right, it checks whether a given attribute or a given condition is in this or not. So let's say I was checking for department name in instructor table. I would check whether a given name is computer science or biology. So let's say I was given a table named instructor. I would be checking whether the department name was computer science or biology. If none of these is satisfied, the table would not print the given tuple in the resultant table. Duplicates, okay. Okay. In relation can set how many copies of tuple appear in a result. Multiset version of some relational algebra operation. Given multiset relation R1 and R2. Okay. If C1 copies of tuple T1 in R1 and T1 satisfied the selection, this, then there are C1 copies. Even I had some problems in this. So let's understand this through question solving. Okay, let's understand this through question solving. Okay, what would be the value of count returned by the following query? So select count from shop and item. So we would be selecting, you know, we would be making Cartesian product of shop and item. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 3, 4, 5, 6, 7, 9. And 1, 2, 3, 4. Okay. So we would be making Cartesian product between these two. Once we make Cartesian product between these two, we would be counting. So what would be the count? I guess I have to take this one call. Let's wait a second. Let's wait a second. Okay, sorry for the disturbance. So what would be the answer of the count? So it is 9 here and 4 here. So 9 4 is 36. It would be 36. The number of the number of tuples present here. Now, what will be the value of count returned by the following query? What would be the value of count returned by the following query? Uh, Again, making Cartesian product, but now shop item number should be equals to item number. Okay, item number and shop item number and item number, that must be same. So that means Cartesian product would be made between 1, let's say 2002, then 1, 2, and then here 1. So it would be actually 9. So let me show you how. Let me show you how. Okay, we need to satisfy this one condition. item number and shop number should be same. Okay, so item number and shop number is same. So this is 1001. Let's check other 1001, right? 1001. First, relation, first Cartesian relation, second Cartesian relation. Now let's go to 1002. So this is first Cartesian relation. This is second Cartesian relation. Now going on to third 1003, 1003. Going on, first Cartesian relation, second Cartesian relation, and third Cartesian relation, right? And the last one would be 1004, that is 1004, 1004, first and second. So how many net, how many tuples would be there in the final table? It is equals to this, the number of tuples in this table, okay, in the greater table. So we have 9 here, and that's what the answer would be. Okay. What will be the value of count? What will be the value of count will be returned by the following query? What will be the value of count returned by following query? Okay. Where shop number 10? Okay. Cartesian product. So let's say we made Cartesian product where the shop number was 10. So the Cartesian product was made between these. Okay. This much. Right? And this much. So the number of tuples would be 1, 2, 3, and 1, 2, 3, 4. 4 threes are 12. There would be 12 tuples in the given Cartesian product. What will be the value of count returned after the query? Shop number would be 10 and item number equals to item number. Okay, okay. So it would be 9. So let me. I think I'm wrong. No, I'm not wrong. I'm just not quite able to make you people understand what I'm saying. So shop number and item. So okay, item number should be same. So that would result in these all of these queries. That is 9 queries. Out of these, only the ones having shop number 10 would be given as an output. So how many are there? Only 3. 1, 2, 3. That would mean the resultant would be only the resultant table would only contain 3 tuples. Identify the appropriate SQL statement that find out all the shop number, right? Identify the appropriate SQL statement. What happened? Identify the appropriate SQL statement that find out all the shop numbers where the item is pencil. So find out all the shop numbers, select star, we are selecting all, and from okay, so we are selecting shop number from shop and item where the item name is pencil. So the third one would be correct. Now how many rows will fetch as a result of the following query? Select all the attributes from natural joining students and department. So natural joining student and department would be, let's find the common between them. Roll number is not common, name is not common, department. Okay, so department and stream have both the same data, so this would be considered equal and same. So electronics would be okay, so my battery is dying. Let me see. A Cartesian product between these electronics 1, 2, and 3. While making Cartesian product, the final would be, see, first, second, and third. Right? This would be the upper half of the resultant table. Now, the computer science branch people that is this much. The this and this would be the low constitute the lower half of the table.